Hello students, I'm your SM ma'am. Today we learn propagation of sound from the chapter sound. In previous class we learned how is sound produced from various objects for the vibration of objects. And today we learn how does sound propagate from the source through the medium. And also we learned that sound needs a medium for propagation, and it can travel through air, it can travel through liquid, it can travel through gases. So let's learn how does sound propagate through different medium. Really it needs a medium for propagation, or can sound travel through vacuum? So how does sound propagate? Now here one person is singing and the audience can listen his voice, and the sound from the singer reaches the audience. So between the singer and the audience there is air. That means through air sound is propagating. In the next slide we learn really the sound needs a medium, or without medium it can travel. For this we learn one activity. You can also learn this activity from your NCERT book, it is given there. For this activity we need a glass and place our cell phone, small size, inside it and ring it, make a ring on it. When the cell phone will ring inside the glass, we can hear the sound from the cell phone outside also. But when the air inside the glass is reduced, that can be done by sucking the air by our mouth. The sound or the loudness of sound will decrease, or the amplitude of the sound will decrease. That means the sound energy that comes out after sucking air, not all after sucking the air, the loudness will be less. That means the intensity or energy also will be less. This proves that the sound needs a medium for propagation. As the air inside the glass goes on decreasing, the loudness of the sound also goes on decreasing. That means if you make a vacuum the glass, then no sound will come out from the mobile phone. As there is no air inside it, sound cannot travel through it. So sound will not come out. Next, from the source, how does sound propagate? The sound travels through the medium in all directions. As you here you can see a dog is barking, and the sound energy from the dog is traveling in all direction, that is in the form of the wave, and it is reaches to the person. That means who are standing in front of the dog, then also he or she can hear the sound, and who are standing the back of the dog, then also he or she can hear the sound. Now student, also suppose you are sitting in a room, and in another room music system is from a music system sound is coming, so you can hear the sound from the music system in the room beside you. That means sound can travel in all direction. Now we learn propagation of sound in air. How does sound propagate in air? Suppose there is a, let us consider a source of sound here from where, suppose this is a loudspeaker or speaker. from where sound is coming out. So when sound comes out, the screen of the loudspeaker or the membrane of the loudspeaker vibrate. As it vibrates and sound comes out, it pushes the particles or the molecules of the air in front of it. As it pushes the particles in front of it, the particles get closer to each other. Then this one also pushes the neighboring particle, and the neighboring particle also pushes neighboring particle. In this way, the sound energy travel from one direction to another direction. Sorry, from one point to another point. And this is the direction of sound energy transfer. Now, when the loudspeaker membrane come back, the particles in the air also come in their original position. So here again the particle become far away from each other and the neighbor particle become close each other. And the next region particles again move away from each other. The next region again the particle will come close to each other. So the region where particle come close to each other is known as the compression region, and where the particle, here you can see, move away from each other, this is called rarefaction region. So by continuous compression and rarefaction, the sound energy proceed from the source. Also, by taking a tuning fork, all of you have seen tuning fork in the lab. Tuning fork is used for producing sound. So when the two arms of the tuning fork are made to vibrate, this arm vibrate like this way. One time they come here, again they come in their mean position, again come to their close position. So when the arm of the tuning fork move outside, it pushes the particle here in the air, for which the particles come close to each other. Again when it come back to its position, the particle again come like original position, and the vibration passes to next neighbor particle. So that means when it comes to its own position, then the particle again come back to their original position, and the compression region travels in the forward direction. In this way, again this one particles transfer the energy to the neighbor particle, and here the compression region create, and here the rarefaction region create. So where the compression region create, in after sometime, then again rarefaction region create. So here the particles do not move from one point to another point. They vibrate about their main position. Only the energy transform from one point to another point. So here the sound energy proceed or propagate by the vibration of the medium particle, and the vibration of the medium particle occur in the same direction the sound energy propagate. That is why sound is a longitudinal wave. And if we draw a graph, we'll get a waveform, and that waveform is for the compression and rarefaction region. So where the compression region, the pressure is more, and in the rarefaction region the particles pressure is less. So if we draw a graph, pressure, and there is the direction or time, we'll get like this way. Here the mean position, the pressure is normal. As we going on, in the compression region pressure is maximum, then again come pressure become minimum, and again when the particle come close to each other, here is the compression region, and here is the rarefaction, again here is the compression. So in the waveform, the crest shows the compression region and the toe shows the rarefaction region. So student, I think you understand how does sound propagate through air, and from where we get the waveform. Actually sound does not travel like that of the wave. It is a graphical representation of the movement or motion of the medium particle, which shows the wave formation. Sound also travel through water. You can do an activity. Take a bucket or bathtub and fill it with clean water, and take a small bell in one hand. Shake this bell inside the water and produce sound. And make sure that the bell does not touch the body of the bucket or the tub. And place your ear on the surface of the water, and you can hear the sound of the bell clearly. That means through water also sound can propagate. Here in this picture there is a ship in the water which producing sound, and the sound from the ship is propagating through water like this way. This is imaginary lines by which sound propagate through water. The animals, water animals like dolphins also produce sound, and the sound can also be heard underwater. That means sound can propagate through water. And in the same way sound propagate through air, it also propagate through water by compression and rarefaction. That means when so students, through water also sound propagate by the vibration of the molecules of the or vibration of the particles of the water. Sound can also travel to solids. When you suppose you are sitting in a table, and your friends also sitting at the other edge of the table, tell your friends to make a sound or strike on the edge of the table at the other side, and you place your ear on the edge of the table this side, you can hear the sound very loudly. That means sound can travel faster in the solid medium. Now in case of air, that means sound can travel all the three mediums. Sound can travel through air, sound can travel through water, and sound can travel through solid. In the air, the molecules are far apart from each other, so from the source it takes time. And in case of liquid, the molecules are little bit close to each other, not like that of the air. You know very well that the intermolecular space in case of the liquid is less than that of the gas. And in case of solid, when sound energy propagate, so the molecules are very closely packed, as you know very well. And so when sound energy passes through solid medium, as the particles are very close to each other, by the vibration and the energy, vibrating energy proceed very fast from one particle to another particle than that of the liquid and the gas. So in solid, the sound propagate faster than that of the liquid and than that of the gas. So dear students, I think you understand. With this video, another link I shall give you, which will help you to learn and understand that sound cannot propagate through vacuum. For this, we cannot hear the sound in the space or the explosion that is going on in the sun. That we cannot sound. We cannot hear the sound that is going on in the outer space, because most of the region is the vacuum. If you go to the moon and the astronauts who went to moon, they also did not hear the voice or the sound from another astronaut because there is no air. So without medium, sound cannot travel, and it is a longitudinal wave.